But I just, yeah.
Okay, so it's 11.22 for our pH. Good. Anybody have any questions about that? Yes?
It's a pretty strong base, right? 11?
Yeah, this is a pretty basic solution. I mean, yes.
But I don't know the weak base.
It is. But it's pretty amazing how even weaks will change the pH from neutral by quite a bit. Yeah, more than you'd expect, right? You think, oh, weak base just changed a couple pH in. No, they changed by quite a bit. Like yesterday, we were doing acids and the pH of acids, and we took a weak acid like acetic acid. It was pretty dilute. I think the concentration was 0.02 molarity of a weak acid. And the pH is all the way down in the 3s or whatever. So, yeah, they changed quite a bit. Philip, do you have a question? Or am I just standing in the way?
No, sorry. I was just like asking about the really
Oh, okay. Now I'm really standing in the way. Would you try this one? Now again, I'm going to ask you to try to write the chemical equation. It's the same thing really as the one before it. I'll give you the K. Oh, I love the K on this one too. Kb for this thing. It is a base. Do you recognize this thing as a base? It's an amine compound, organic with nitrogen in it. Kb equals 4.4 times 10, guess.
-8.
No, it's the negative fourth. 4.4 times 10 to the negative 4. Isn't that good?
That's 2 times.
Oh, to the negative, that would be good too.
But where does the H go? Does that matter?
What H?
On the end.
At the end, alright.
Because the N has a lone pair on it. That's what makes it a base. The hydrogen ion likes that lone pair on the end.
So, if it's not organic, is it always going to be a base?
No, because you can have organic acids too.
It's not even a base. It's just like,
Organic with a nitrogen in it, that's going to be a base.
when they're like, just
And then organics with an acid, like acetic acid. When you see a COOH at the end, it's going to be an acid. That's a carboxylic acid. So you see organic with the COOH, that's acid. Organic with an N, that's base.
well, that's just like without organic.
To the -5.
There is an example in the
I'm going to, let's go through this one. Just assume this is a base. Then on the next problem, I think it's the next one, I'm going to show you examples of where, yeah, you're going to have other organic kinds of compounds. We'll talk about that. Yeah, it's implied, so you'll know which it is. And there's a table of acids and bases too, and you'll be able to find on one of the tables.
Oh, that's the tables?
Yeah.
Mr. Moore, why would the H go with, oh wait, CH3 and H2? Is there another pi bond in there? Or is it just one single bond?
All single bonds. All sigma. Did you write an equation for it? Can I uncover the equation just to make sure that we're together? Hopefully you got it. It's like this one we just did. The base takes the hydrogen from water, so you have to have water as the reactant, other reactant. And then you get the extra hydrogen on that amine compound, plus the hydroxide.
Oh, you can? Wait, I don't think it matters though. No, yesterday's,
You want to write equation?
I know, but
No.
yesterday's question.
Because I
it was about
assumed that you
5%,
know.
But it was only like a point.
And when you write your K, I'll know that you know.
Okay, try it out. Tell me if it's weird. Yeah, do it by the.
Wait, Shani.
What are you saying? I mean, I know what you're saying, but why are you saying
And then
that?
I took the -1.
No,
Because POH plus pH equals 14.
Is he just encouraging you?
Yeah, POH is the base, right?
Yeah.
Did you find the pH here?
No, I found the POH by putting -log of whatever you got.
You are literally not that.
Yeah, but it's not good.
Like, you're overreacting. You are so dramatic.
I have to use my like legs. I can't use my
You're so lazy.
No, it's not.
Like, your dad would not hurt that bad. You would go home.
I know. Oh, he's graphing. Oh, what's
If you
this
should
going
really
for?
learn that much people. I did that too.
Why? Why can't you go home?
It's close to zero, that's why.
You're right.
Why would you go out to the back?
Oh, it was 0.0002 off.
Really?
11.81.
Yeah, what'd you get?
Yeah, it should be 11 point something again.
Yeah.
It's not the same number, but it's pretty close.
So it has something.
It's,
you're right.
What's the actual answer?
4 point.
11.81 number one.
Yeah.
11.81? Yeah, that's negligible.
Yeah, 11.82.
Didn't we establish that last time?
Oh, so more use 0.00.
This is what I get using the 5% rule for the hydroxide concentration.
Yeah, and it's not.
And then the pH, after you do the POH, looks like it's gonna, yeah, go ahead.
The 5% rule doesn't work because if you took it over, the original concentration would be over 5%.
Is it around 6%?
Yeah.
Yeah, just use it. Use the 5%. I am straying farther and farther away from 5%. Even yesterday, one of our examples had like, it was off by 18%. 18, was it 18%?
Yeah.
But the final answer was really close to what you would have gotten with the quadratic. So, yeah, if you're even close to 5%, plus or minus another 5, use the 5% rule.
Okay.
So even in this case, just use it.
Okay.
So if it was like 10%, it's still use it.
If it's 10%.
Yeah, don't tell anybody who told you that though.
It's on video though.
Oh, for the whole world. Okay, so anyway, the pH is 14 minus 2.18, which is 11.82. Anybody have any questions about this one? You feeling okay about that?
Why wouldn't it make it linear when they first made pH and POH? Because it's really hard to imagine how basic it is when it's exponential. Because like as you get closer and closer to 14, the numbers start to increase even smaller, more smaller. Right?
Oh, every unit of pH is going up by a factor of 10.
No. No, but e to the power of that, right? So it's
10 to the power.
10 to the power.
Oh yeah, it's 10 to the power, so it's exponential. But if it was linear, so we could actually imagine.
You can't imagine.
Why are you complaining about that? Are you just trying to come up with something to complain about?
No, because like these values are so close to each other.
Why are you not complaining?
Even when they're like one is a really weak base and one is a really strong base. And they're at
Just do me a favor, write all this down. I'll read it later.
alright.
Okay?
Yeah, you don't need to say
Oh, I will. I will.
Okay.
You can trust me.
You stay as you every day.
All right, before I go to the next slide, I want to mention something. This is going to not settle well with some of you at first, and I'm hoping that over time you'll kind of get the feel for it. We talked about Kw. Kw is the equilibrium constant for this reaction. Water dissociates a little tiny bit. It breaks into hydrogen ions and hydroxide ions. Does this make water an acid?
Yes.
Yeah, it gives off hydrogen ions. It's an acid. Does this make water a base?
No.
So would you agree that water is kind of an oddball? It's an acid and a base at the same time by doing this?
I forgot the word.
It's amphoteric. Yes. Now, we decided that Kw is the equilibrium K expression for, or the K value for this reaction. Because it's an acid though, wouldn't you also have to call it Ka?
Yeah.
Because it's releasing hydrogen, and you'd have to call it Kb because it's releasing hydroxide. What happened?
It's okay, Mr. Water.
Don't you break that thing.
I would've
Okay,
done-
so anyway, distractions aside, the Kw for this thing is the same thing as Ka because it's an acid, and it's the same thing for Kb because it's a base. Now, yesterday I told you this, that Ka times Kb is equal to Kw. That's for everything else except for water. You need to get your fingers around that. Some acid like carbonic, no, not carbonic acid, diprotic. Salt, no, not sulfuric acid either. Nitrous acid, HNO2. HNO2 has a certain Ka value. NO2 negative is its conjugate base. It has a certain Kb value. Ka times Kb is equal to Kw. That's what I mean by this thing. But when we're talking about water, specifically and only water, then the Kb and the Ka are equal to Kw. So Kb of water is 10 to the negative 14. Ka of water is 10 to the negative 14. What I'm saying is water is a very weak acid and a very weak base. Can you buy that? You're going to want to say that the Ka for water is 10 to the negative 7th, because it would be like the square root of K. Like that times that should give you 10 to the negative 14th. So for water, that should be 10 to the negative 7th. That should be 10 to the negative 7th. I'm telling you, that's not right. They're both 10 to the negative 14th because this is not true for water. It is for everything else. Oh, I love the sound of people biting into carrots. Please continue biting into carrots. It's such a great sound. I love it. I do. No, I love that sound. Crack. It's carrots are so great.
What's up with that?
I really don't even like eating them unless they're cooked, but I like people eating them. So thank you, Philip. It just makes me happy. Go ahead. Oh! Okay.
Oh, easy carrots with your
All right. So now, having talked about that, this is a problem. If you've started the exercises in the book, you'll run into questions like this. Now, after we're done with this one, I'll show you where you'll find it in the book. We have 4 bases up here. Would you agree that all 4 of these could be considered bases? Because they could all accept a hydrogen. One of them not very well at all. It should stand out.
ClO2.
I'm asking you to rank these in order of their strength as bases. 1 being the weakest base, up to 4 being the strongest base. Would you take a second and write these 4 things down? These 4 bases down? And then I'm going to show you the Kb table in the book.
Wait, so 1 being the strongest?
1 is the weakest, no, from weakest to strongest. So,
HClO3 is a strong acid, but what about HClO2?
nope.
All the electrons are going towards the O bond, and so the hydrogen is forced to break off.
Not as easily as if it's ClO4. You don't have it already.
Right. So then, what's more basic?
Hold on.
Cl or ClO2? ClO2 is more,
He said hold
less
on.
basic, right?
He said hold on.
Hold on.
Oh, okay. I'm Bruce Lee.
So if we're comparing strength of bases, maybe we go to the Kb table, because wouldn't you agree that the stronger base is going to have a higher Kb? Well, there's a problem here. None of those things are on the Kb table. What else can we look at then?
Online.
No.
No.
Over here, would the Ka table help us at all?
No.
Yeah.
Poker.
It would, because of this thing right here. If you know the Ka of an acid, then you can find its Kb of its conjugate base. And that's what we're going to do with this. Now, one of your choices was ClO2 with a -1. I don't know what its Kb is, but I do know that HClO2 has a Ka value of that. And then one of them was Cn negative. That's cyanide. HCN is right here. So the Ka of HCN is right there. So I'm going to go back to this. And over here on the left, I'm going to write down what the Ka values are for HCN. I don't mean concentration, I guess. That's not what I mean by concentration. That one, HCN, was 6.2 times 10 to the -10th for Ka of that thing. HCl. Now, what's the Ka of HCl?
Infinity.
Yeah, it completely breaks apart, so it is infinity.